Hey there, folks, ladies, gents, boys, and girls. Today we are going to discuss conditional probability with a focus on Venn diagrams. Now, a quick little reminder for conditional probability, that would be the probability of A given B. And sorry, my parenthesis is a little square there, I goofed. The way we'd calculate that, again, for conditional probabilities is up top, you would say the probability that both A and B occur over the probability of B. So conditional probabilities, as a reminder, we're kind of narrowing our focus to just the second outcome and saying within that second outcome, what's the probability that the first outcome could happen. All right, so Venn diagrams, as we hopefully know, are two overlapping circles. What's in the middle, this would be the intersection of the two sets, so something that satisfies both criteria. Sometimes you might see a third circle in there. That is totally possible. And we always surround these with a rectangle. That rectangle represents the universal set, so the total number of elements in the set. So we always have to make sure that all of the numbers here, 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 and then we put it in the bottom corner, they have to total up to be the overall total. So let's see an example, shall we? And by the way, before I get too far into this, these notes are online as well. So if at any point you need nicer handwriting, which I won't be offended if that's the case, you can always access that through our course schedule. All right, so we have a class. Within this class, we have the probability that we select a male is 0.30 or 30%. Probability that someone with a brown hair, whether it's male, female, who cares, is 50%. And then the probability male with brown hair would be 20%. For me personally, it's easiest if I just pretend that there are 100 total people in this class. Obviously, that'd be an enormous class, but it makes things easier for the sake of argument here. Let me see if I can adjust the camera a bit to bring it in. Come on, big money, big money. All right, so if there are 30% male, if I call this circle males, well, that just means this entire circle had to account for 30 people, right? If I assume there's 100 total. Over here, I'll call this brown hair, and this entire circle has to account for 50. Now, the overlap is typically where I want to start, and we have 20 people that are both male and have brown hair. Now, I know this male circle has to have 30 total. Well, there's 20 here, which means there would be 10 over here, right? 10% of the overall population. If I'm assuming there's 100 people, I'll just say 10 people there. Similarly, we have 50 people total in the brown hair circle. Here's 20. I need 50 total, so this would be 30 in here. Well, if I've got 10 here, 20 here, 30 here, let's see, 10, 20, that would be 30, 30 more. Right now I'm at 60, okay? So there's 60 total people accounted for, which means there would be 40 that were unaccounted. So these 40 people represent people who are not male and do not have brown hair. Maybe they're female blondes, maybe female redheads, maybe they got, creative and dyed their hair purple. Who knows? Okay, so we want to know what is the probability that a student is picked at random. I want to know the probability that they are female. Well, I know probability of male was 30%. So anyone not in the male circle, we would assume then would be in the female circle. So there are 70 out of the total 100. All right, well, that's just 0.7. Or if you're a fan of percents, 70%. Either one is totally fine. Next step, probability that they are male given that they have brown hair. So here's where I'm going to narrow in my focus. I'm only focusing in on that brown hair circle. I want to know what is the probability that they are male given that they're in that brown hair circle. So I need the probability that they're both male and brown hair. And I'm going to divide that by the overall probability that they had brown hair. Well, there are 20 in that overlap. In the overall brown hair circle, there are 50 people total in there. If I do that arithmetic, let's see, 2/5, that would be 0.4, or if you like percents, 40%, either one completely valid. Next one, probability that they are female given that they do not have brown hair. So I'm going to call that not brown, NB, not brown. So we've got the probability that they are female and not brown, all over the probability that it is not brown. Well, let's see. The not brown is basically anyone not in this, not in this circle up here. So there's 50% who had brown. That means there would be 50% who do not have brown hair. That looks like 56. That's my fault. Next up, female and not brown. Okay, well, I'm kind of narrowing my focus to anyone not in that circle, right? So I have 10 here, 40 here. That's where I got my 50. Of those 50, 40 of them are female and they don't have brown hair. So this would be 40 out of 50, which would be 0.8 or 80%. All right, next example. Freezy's Iced Creme stand is testing out 2 new flavors, birthday cake and daddy cotton candy. Dandy cotton candy. Daddy cotton candy. That'd be weird. So birthday cake, and I'll call this B for birthday, and then C for cotton candy. All right, so we had a poll. It says 32 customers liked birthday cake, 58 liked cotton candy, 12 liked both, 22 liked neither. All right, they didn't really tell me a total, but I could do some quick arithmetic and I could figure out that total. Let's go ahead and fill in our Venn diagram though. We always like to start in the middle, so the overlap here. Who liked both? Let's see, 12. So 12 liked both. Okay. So now if I'm talking about birthday cake flavor, 32 total in that birthday cake circle. I've already got 12 accounted for here, so there would be 20 left, because 20 and 12 makes that 32. Same idea. 58 total in the cotton candy circle. Well, here's 12, so this would be 46, and they told us the 22 out there. So now if we add those together, you might be able to do this mentally. You might need a calculator, whatever. You do you. 20 plus 12 plus 46 plus 22. We get a hundo. Sweet. I love it when things work out to be 100, because then we can just take things as percentages. That's great. What is the probability that a customer selected at random would like dandy cotton candy? All right, well, we have 58 out of the 100, so that's just 58%. Or 0.58 if you'd rather write it as a decimal, 0.58. What is the probability that a customer selected at random would like either birthday cake or dandy cotton candy? Now, here is where you can get a little bit dicey, because they didn't include the phrase or both. All right, so I'm actually going to go ahead and assume that the or both would be included. And really, that's just a matter of, do we include these 12 people or not? So if we didn't, it would be the 20 plus the 46. If we did, it would be the 20 plus the 12 plus the 46. So this is probability that someone likes one or the other. They like one or both of those flavors. So we'd have 20 plus 12 plus 46. That's 32 plus 46 out of the total 100. I want to make sure that I'm not going up here and just adding these 32 and that 58, because then I would double count the overlap people. So 32 and 46, when we add those, we get 78 over 100. So that'd be 78%. Not sure why I circled that one and not this one. Whatever, don't want to play favorites. All right, so that tackles Venn diagrams. Next step, this table is supposed to be a surprise. Act surprised when I unveil it. A two-way table is a table that gives us two different types of information. We have columns and rows, 2 dimensions, ergo two-way table. So here we have a study of exercising habits, married people versus divorced people, and those who were never married. So what we want to do is kind of figure out a table that we could fill in the blanks for married, divorced, or never married, and do they or do they not exercise. So here we have 300 married people. So I know this total down here is 300. So this was given to me from the problem. Out of those, 200 exercise regularly. Well, if I know there's 2 out of 300, I could figure out the remaining would be the 100 here. 150 divorced people. So they give us that total there, and they tell us out of that 150, 100 exercise regularly, so they give me that piece of info. I can then work backwards to figure out the remaining would be 50. So the totals kind of work down. We do the same thing for the people who are never married and their exercise habits. Again, we would add down, and it should check out. From there, we can also add across. So we're going to have the total people who exercise, total people who don't exercise, the total married folks, total divorced, total never married. Whether I add across this way or add down this way, I should get the overall total of 550 total humans being surveyed. So now let's get to our probabilities. I want the probability that they are married given that they exercise regularly. So this is going to be the probability of both over the probability of the regularly exercisers. Essentially what I'm doing is I'm just narrowing my focus to the exercising people. So out of the 340, how many of these people exercise? That would be 200. So I would calculate this by taking 200 out of 340. All right, well, that's straight calculator work now. 200 divided by 340. Let's call that 59%. 59%. Number 3 says the probability that they do not exercise regularly, given that they were never married. All right, so if they were never married, I'm going to look at that middle column, or sorry, that third column. There's 100 total people, and of those 100 total people, 60 do not exercise regularly. So 60 out of 100, well, that would just be, hey, that's 60%. Remember, we like 100s as our total. The probability that they were divorced, given that they exercise regularly. So again, the regularly exercising, that's where I narrow my focus. So I'm only looking at the regular exercisers, these 340 people. Of those, we have 100 who are divorced. So we'd have 100 out of the 340. We go to our calculator. We would get 29.4%. Lastly, the probability that they're either married or they exercise regularly. So they're either married or they exercise regularly. Basically, are they either one of these 300 or one of these 340? So we might logically think, hey, there's 640 people who fall into one of those two categories, right? Well, the issue is we kind of double counted this 200 here. So I need to subtract away that 200 that I double counted. So I'm adding each independent probability, but subtracting the overlap. When we do that, we would get 440 out of our total 550. And that's just an overall total because it doesn't have a conditional clause to it. We would get 80% for that. All right, so that's conditional probability with both Venn diagrams, the circles, and then two-way tables, which a lot of people kind of think these are more easy to navigate. If you're feeling adventurous, let me zoom out a bit. Go ahead and pause the video here. Actually, you know, we'll go ahead and end the video here. But try to figure out where these values in this table came from based on these 4 bullet points. So see if you can reverse engineer this table based on these 4 bullet points, and then I will pause the video here, I'll throw the answers on, and then I will reveal the answers and see how you did. So right now I'm going to pause. All right, as promised, here are the answers, so go ahead and kind of self-check on that. Right here, you'll see I have the overall total of 96 because they didn't give me a conditional clause. Here I have the total of 37 because they give me the conditional of can't swim, so there are 37 folks who can't swim. Here I have the condition that they are 6-year-olds, so there are 30 total 6-year-olds here. All right, that's it. That's all, folks. If at any point you have a question, please do not hesitate to reach out. Good luck.